Well, hello, Cal State Straub. We're going to continue today learning more about confidence intervals, and we're going to focus entirely on means for these next 2 days on section 10.2. Okay, so, whoa, you're seeing my computer. This is kind of weird, huh? All right, let's just get into it. What we've done so far is when we're looking at mean is that we've been using sigma. That's what we looked at in section 1 when we used z star. We're getting our little French character. Sorry, just have to have a little humor in here. Z star. Okay, z star was the critical value when we knew sigma for when we're locating values for the mean. Okay, but as we've talked about already, it's pretty unrealistic to know sigma. That is the standard deviation of the entire population. So we estimate using our sample standard deviation, which is little s. Okay. So now the formula stays basically the same, except for you're just replacing right here s in place of sigma. Okay. Now this distribution is no longer z, it's not normal, and I'm going to show you in a minute on your formula sheet the shape that a t distribution does take, but it is a t statistic now. It's called a t distribution, okay? And that's what we're going to get into today. And the thing is weird is that t is different for every single sample size. There's a really cool bingo game that I'm going to try to figure out how to have us do it online. We'll get this figured out. That we'll play in a little bit later. I think it's chapter 11 or 12. I'll show you how tea was created. It was actually a guy who worked for Guinness Brewery in Ireland, and he in the 1800s developed this different tea for every single sample size without calculators, without computers. So we'll talk about that. But you'll see the notation here. Then it's called T of K, where K is going to be called the degree of freedom. I don't see the K very often. Usually now you'll see DF for degree of freedom. Let's talk about what that is. But before we do, you need to have out your tables, your formula sheet from AP formula sheet that has the tables in it. So if you need to pause me and go get that in front of you, it's a must to have right now. Okay. So we're going to look at a one sample T interval where we're just taking one sample of data and we're going to do a confidence interval on that data. And it's called a T interval because that's the procedure I'm going to use when I don't know sigma, the standard deviation of the population. So hopefully your formula sheet's with you now. It's either table C in the back of your book or it is table B on the formula sheet. So I'm going to pull it up here in just a minute. Degree of freedom here, that DF is actually going to be your sample size minus 1. So if you have 20 items in your sample, your degree of freedom you'll use on the table is 19. Okay. I'll read this to you. Sorry. I'll read this to you right now, but I'm going to go to the table and show you what I mean. If the actual DF is not on the table because it quits counting by ones eventually, that would be forever, then what you do is you use the greatest degree of freedom available that is less than your degree of freedom. So if your degree of freedom was 62 and there's no 62 on the chart, then you would go to the closest one, which I believe is 60. But we'll pull up one right now. Let me go to my table, pull that up. So this is the one you should be looking at, table B, T distribution, critical values. Okay. What I don't like here that AP has done is they have made this T distribution look normal. And I just got through telling you it's not normal. It's a little bit, we'll talk more about that later, but it's not exactly normal. It depends on the size of N. As N gets larger, it gets more and more normal. So it depends on N. All right. But let's scroll down if I can over here. If you look at the left-hand side now, you see DF. And DF goes 1, 2, 3, 4, 5, all the way down here. It's counting by ones until it gets to 30, and then it starts jumping up and down. Okay. So here's how you're going to read this table to get your T-star. And I'll come back to the notes and keep going this. But as you're looking at the table, so let's say your sample size, like what I said earlier, was 62. If my sample size is 62 and minus 1 is 61, I look at the table and I don't see a 61. However, the one that is lowest, because we want to make the most conservative, this gives us the most conservative estimate. It'll make our interval a little bit bigger, okay, but it's going to be our conservative estimate, and we don't want to miss it by rounding the wrong direction. So we're going to round it conservatively. So you're going to go to the 60 right here. Okay, now here's the cool thing. If we're doing a 95, I showed you this in 10.1 notes where you can find when you get to Z star to infinity, here's all your Z stars across the bottom. But you go over to 95% CI right here. And if 62 was my sample size, then the T star now, not Z star, but T star that I would use would be this number right here that goes with 60, because 60 is the number right before my 61 that I would use. If degree of freedom was 61, don't go above it, go below it, the very next number below. If my CI was 99%, then I would come over here to the 99% CI and follow that up to 60. Where is that right there? And use that number right there as my T star. Okay, so let's go back to the notes. Hopefully, from current slide. Okay. And I just now showed you this. Where's my, let me get me out of the way here a little bit off to the side. Oops, go back. So you go to that desired confidence level that I just showed you and get your T star. And then I just said, please notice that the T values were getting closer and closer to that Z star as N increases. And that's what I kind of said earlier, as N gets bigger, you're getting more and more normal, okay? So remember, sigma is unknown, okay? So the formula for our confidence interval is so much the same, except instead of Z star, we are going to use that T star from the table. And remember, it depends on N, whereas Z star didn't matter about N. Z star, you just went, and it's the same no matter what. But now when sigma is not known, we're going to do a different procedure and find that T star. And then the only other difference here is that we're using that S, okay, which is the standard deviation of the sample, okay? That's our little, this whole thing right here is called your standard error of the mean, okay? And in the pink box, this whole part is our margin of error. Remember, this is your sample mean, always in the middle. Then you're going outside of that, this distance, and the distance that you would go out from it would be this margin of error when you multiply all of that together, okay? So it's the exact same formula we used that I showed you in 10.1. It's just now you have T star instead of Z star, and you have S instead of sigma, okay? And then this interval will be an exact interval if you know that your distribution is normal. Otherwise, it's going to be approximately correct for large N. When N gets small, this procedure doesn't work very well. And at the end of this lesson, I'm going to show you those rules. Okay. So if N is large, greater than 30, our CLT thing, we remember CLT, we can assume normality when N is greater than 30. When N is less than 30, we got to do a couple of other things. And like I said, at the last slide of this lesson, I'll go through that with you. Okay. All right. I just need you to remember we did a while back a probability plot. A probability plot is great to help you to see if your data is normal. Okay. Because that's one of the things we have to do in order to run this procedure. Remember, one of our conditions is this data set normal? And CLT, if it's greater than 30, fine, we're good. But if it's not greater than 30, we need to go look. And so you're going to put your data into your list, and you're going to run the stat plot, which I showed you as the sixth plot over on your screen for the TI 8384s. And then when you hit zoom 9, you're going to look at that. And if they're fairly straight in a line, then you could say, Based on my plot, this data is approximately normal. So when you're running your conditions and normal is one of the conditions, if n is not greater than 30, then you can run your plot and say, here's a sketch. You'll have to put that on your paper, a little sketch of your plot, just what it looks like, and say, based on my probability plot, they're fairly linear, so we can assume normality. Okay. You can also look at a box plot, histogram, probability plot, using your 1-var stats to just see if it appears normal. Other graphs can give you some idea. And I really would recommend that as we go through this next example and you're putting your data in, that you run a couple of the plots and just see, does it look normal? Okay. Your box plot will be, if it's normal, you're going to have a good, consistent box plot going across, no skewing. And of course, your histogram, you'll see the curve on this probability plot with a straight line, okay? If n is less than 30, notice this down here, you cannot have any outliers to use this procedure. So if you have, even it looks like a straight line, but there's a major outlier, then we cannot use it. Or we would say proceed with caution. Remember how AP Stats wants us to do that. Even if we find something that's not quite met, we need to state it and then proceed with caution. All right, so let's do an example. You're going to run your state, plan, do, conclude, just like we've done before. But here's your question. Number of minutes it takes MVHS students to get to school, and here's some data. So take a quick second and pause the video and put these numbers into your L1 for me. Okay. If you have your data in to your calculator and you push play again, here's your state. Basically, you're stating we're going to construct a 98% CI for the mean time to get to school. Now, when I look at this data, do I know the sigma standard deviation for the population of MVHS students? No, all I have is a sample. So I know I'm going to be using T-star now because I'm using a sample standard deviation. So the plan is just like before. We need to check our conditions. So the first condition is it an SRS? Well, this time Miss Straub just grabbed some data from AP Stats students who were in a period 2 class. That was not random, so we need to proceed with caution, but it needs to be an SRS out there in the world that we're looking at, okay? Is it normal? Well, did you run your probability plot on that? If you have not yet, pause me and run your probability plot and see. It should look fairly linear to you, but I want you to double check. Okay, if you've got your probability plot done, and you could say, hey, based on that, by the way, why am I running a probability plot? Because I cannot use CLT. I only have 15 is n. N is less than 30, so I need to go use another method to figure out if it's normal. And then finally, your big number set that we've been doing, which is also now determining if they're independent or not, and that's that 10n has to be less than or equal to capital N, and 10 times 15 definitely is less than all the MVHS students. So I have done my state and my plan, so I'm ready to do. So let's calculate. Okay, so I put up here our formula, that x bar plus or minus T star times S over root n. You hopefully can go run 1-var stats if you have not already. That's where these numbers came from, was 1-var stats. So again, if you need to pause me, run 1-var stats and make sure you get those numbers so that this is making sense to you. Don't just listen, do. All right, if you've got that in your calculator, here's what I got. I got the x bar, the mean from our sample, x bar, and the S from our sample, the standard deviation of our sample. Oops, sorry, is up here in the purple, 4.995. This is my T star in pink here. From the T chart, I use DF14Y because 15 minus 1, you always take n minus 1. So make sure you have your chart in front of you still. Go down to DF14, go across and encounter that CI, the confidence level of 98%. Follow that up and you'll see 2.624. Okay. Doing the math for this, I get my confidence interval as you see it here. So of course, now we need to conclude. State plan do conclude. And that's our we are. So we are 98% confident. The mean time to get to school, notice the context is going into our conclusion. So the mean time to get to school for MVHS students is between 5.28 and 12.05 minutes. However, in your conclusion, you should always state your caution. Caution, it was not an SRS. So this is possibly not accurate because we did not meet all of our conditions, right? Hopefully this made sense. What we're going to do is you're going to do a turn and you're going to put your work into Edpuzzle for me. Okay. So let's give you the example. MVHS students, move me out of the way. Okay. Were asked at random the difference between their math and English final exam scores. And here are those differences. When I count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is 10. N is pretty small, so I cannot claim CLT. So I want you to tell me what you're going to do here, remembering that you're going to state the problem. The problem is that I guess I didn't tell you what percentage CI, huh? So why don't you do me a favor? Check the conditions, and then I'll come back and tell you what I have it here. Hold on. We're going to do a 95. Oh, yeah. Remember when it doesn't tell you the confidence level? If it's never there, then you always use 95. That is our go-to number. Okay, so 90. You're going to create a 95% CI of the mean difference between the math and English final exam scores. Okay, so go to Edpuzzle and come back. Okay. And sorry about the noise in the background. So check conditions. Let's see how we do that. SRS was given. So there you go. It says here they were asked at random. So that was given. 2, normal. Did you check a probability plot and see? Okay. Number 3 is 10N is less than or equal to capital N. So that would be yes, because 100 is less than Mission Vista High School population. Okay. So there it is. Now, go ahead and create a 95% CI, and Edpuzzle will stop you here and ask you to give me your CI and your conclusion. Okay. All right. Let's see here. Did you get? If you plugged in the formula, this is how it should have been plugged in. There's our X bar after getting 1 bar stats run on your calculator. Here's your T star. There were 10 items. Is that right? So DF of 9. And then here's your standard deviation of the data set. Yeah, there we go. Your DF is 9 and the C level was 95 on the table. So here's your CI that you should have gotten, and your conclusion will be we are 95% confident the mean difference between math and English final exam scores is between 4.78 and 13.83. Okay. Woohoo. I got a blank. Way to go. All right. Remember earlier I said that we just have one other thing to think about, and that is when using our T star. Okay. These T procedures, it's called a T procedure for a CI. Except in small samples, and this could be a multiple choice question on the next test. Remembering that SRS is probably the most important thing. That's more important that it's random then that is normal. Because when n is large, we get more and more normal anyhow. So anything bigger than 30, we know we can assume normality. So the main thing you're going to make sure to look for every time is it simple random? Okay, but what happens, Ms. Straub, when it's not greater than 30? What do I need to do? All right, here's the parameters that are given to us. Sample size, if it's less than 15, use T procedures only if your data is close to normal, if it's really close to normal. Do not use T if data is clearly non-normal or if there's any outliers. Even if it looks normal and there's a big outlier, no, okay? But what happens when it's between 15 and 30? The T procedures can be used except if there's outliers or strong skewness. So it doesn't have to be as normal looking. It can have some skewness, but it cannot have strong skewness. Okay, well, that's just a judgment call from the look of it. And then, of course, once it is greater than 30, it can be used even if your data set is clearly skewed. That doesn't matter. We've looked at that in previous chapters where when I showed you the CLT, it just at any time we still end up with a sampling distribution of all of those sample means coming in that goes normal, okay, as long as n is greater than 30. All right, so now hopefully you have printed out the worksheet. Let me get that up for us. This constructing a confidence interval for a mean, and you have this by you right now to work on. If not, you need to get that handy for you, or you need to have it on your screen while you do some work on that. What I'm going to ask you to do is, based on the last screen I just gave you, I want you to read through these different scenarios on this worksheet and determine, it asks you here, determine whether you can safely use T star or not. Sorry, let's get this good. Okay. So, for example, look at letter A. How about if I start A with you so that we get an idea, and then I want you to try to work on the others. You want to estimate the time in minutes to order and receive a regular coffee at a local coffee shop, when we can do that again. The time for 5 randomly selected visits to a local coffee shop are shown in the dot plot below. So this does not include waiting in the drive-up, which is the only way we can get coffee at this time. So you look at that. What is n? Oh my gosh, n is what? 1, 2, 3, 4, 5. N is 5. Very, very small. So if n is 5, it must be exactly normal. And as I look at that, way out here appears to be an outlier. If I didn't have that one, I could say this appears to be normal and I could probably use the procedure. But because of this outlier out here at about 6, I cannot safely use T star. So why don't you do B, C, just B and C. Try those two and then come back. I'll have you put that into Edpuzzle and we'll come back and talk. Okay, did you do B and C by yourself? And let's see how you did. In this case, we say we want to estimate the average height of high school students. And so here's your box plot for 100. So can we safely use T star? And I hope that you easily wrote down, yes, we can. Why? Because n is 100. Anything greater than 30, we are okay to go. And even as we look at it, it looks fairly normal. We do have outliers, but it's okay to have outliers when n is greater than 30. CLT applies. Okay, let's go to part C. A middle school counselor wants to estimate how many minutes an average student spends doing homework. So here's your histogram of 20, random sample of 20. As we look at this one, I don't what your thoughts were. 20. It's less than 30, so I can't use CLT. For the most part, this data set is fairly normal. This right here is a little troublesome, possibly, but overall, its shape is fairly normal. So we would have to state that. Here's a sketch of our histogram, like in your conditions when you're doing the problem. Here's a sketch of the histogram. And, excuse me, goodness. And then state that it is fairly normal. We wouldn't say it's strongly normal, but it is fairly normal. So we would go ahead and proceed. There's no outliers that are perceived on this. So it's okay. Remember, it's got to have strong skewedness when you're greater than 50. And this is not majorly strong skewedness. Okay. Down here at the bottom of your worksheet, it asks you to do some simulation and see what's going on. On your own time, you can run that on your TI. Basically, when I ran this, I see that it's pretty much skewed left, skewed left, skewed left for a while. As I did several of them, I got one that was more normal. Okay, but remember N is 20 here. And so we're going to have a little bit of issue going on with that one. So I'm not going to worry too much about that one. That's just something that you can challenge yourself to look at and see if you can see what's going on there. All right, but here is what I want to spend the last few minutes of this lesson today on. And that is practicing one before you get to your homework tonight. So now you're going to construct a confidence interval for a mean. That's what we're going to do. 4-step process. What is the 4-step process? State, plan, do, conclude. Okay. So here's pretty interesting that it's a test on toilet paper. I just realized that this is hilarious. In this time where we probably would not be using toilet paper at this point in time to do AP stats testing because everybody is hoarding it, unless you're a person who hoarded 1,000 rolls at the beginning of all this. But so as part of their final project, they wanted to, they got 18 rolls of a generic brand of toilet paper to measure how well the brand could absorb water. So to do this, they poured a 1/4 cup of water onto a hard surface and counted how many squares of toilet paper it took to completely absorb the water. And then here is the results from their 18 rolls. Okay, so this asks you to construct and interpret a 99% CI for the mean, the true mean we're trying to estimate. Remember, the whole purpose of confidence intervals is to estimate the true mean using samples, okay? So we've got all these sample means that we've taken now. Now we're going to do a sampling distribution of this and get a confidence interval. 99% is pretty high confidence, so our intervals might be a little bit bigger as we learned last section. Okay, the mean number of squares of generic toilet paper needed to absorb 1/4 cup of water, that is our parameter that we are estimating about. So notice the state is already done for us here. So this is your state. If you want to write state right to the left of this and put brackets around it, this is what we are doing. That, remember, the state must include your parameter, context, and your CI, and that's all there. So now all you need to do is if you'll finish this by doing plan, do, conclude. So get your conditions underway, your 3 conditions, SRS, normal, independence. Do those 3 checks, and then do your formula, come up with your CI. We are using T-star here because there's no standard deviation of the population of all these toilet paper rolls. This is from the samples, so sample S, T-star for your do, and then write a conclusion, and I'll come back and show you mine. Add puzzle, pop in. Okay, let's see how you did. We're going to go to the back of this worksheet. Okay. I just happened to restate it. We want to estimate the true mean number of squares of generic toilet paper needed to absorb a 1/4 cup of water. Okay. The mean is okay, so let's go to the plan. We're going to construct a 99% CI. So I'll talk more about this later. As we get going in every chapter, we're learning a different procedure. Already you've learned 2. You did a Z procedure for mean when standard deviation is known, and now we're doing a T procedure, T interval, when sigma is not known. And then we're going to have one sample, and later on you're going to add two samples. So what AP Stats really likes to see is what I've done here when you're writing your problem out, that you state what procedure you're doing, that you're doing a one sample T interval procedure, okay, for the mean. So if conditions are met, we're going to look at this. Okay, N was less than 30. Okay. Oops, I didn't. Oh yeah, here they were randomly selected. I should have put SRS separately. Sorry, I did this before. I really organized myself. The roles were randomly selected, so make sure you have that somewhere. That was given. Put it in here. Then N is less than 30. So for normality, we had to go make a graph. Here's a sketch of my histogram. And I put it's fairly normal and there's no outliers. So therefore, I'm going to go ahead and proceed. Independence, 10N, 180 would be definitely, there's at least 180 rolls of this brand out there. Or maybe not the way things are now. Okay, so then here's your do. I just happened to rewrite the formula. I did a 1 var stats to get X bar and S. Okay, my degree of freedom, I'm writing all my information down just so I have it handy. From 1 var stats, I got those. The degree of freedom is 17 and minus 1, and the confidence level is 99. So on the table, that you should have gotten the 2.898. Okay, so here is the formula with everything plugged in, and I got this interval here. So our conclusion will be we are 99% confident that the interval from 22.95 to 26.85 squares of TP will capture the true mean number of sheets needed to absorb a quarter cup of water. Making sure you have your confidence level in your conclusion, your interval in your conclusion, your context in your conclusion. And then finally, just like we talked about in 10.1, you're going to make a quick sketch. This is 99%. Sorry about that. You see 99 barely here in the middle of this center section. Our mean, sample means, the means of all the means was 24.9. And then here's my end caps, 26.85, 22.95. I know that I am going 2.898, almost 3 standard deviations away from the mean there to get out there. And then that's just shaded in here that I know 99% of the time we will capture the true mean in that interval when we take a sample. Okay. All right. That's it. We'll continue with just a little. You'll be happy that the next note sheets is really small, very small. Okay. Just had to figure out how to shut us down. Oh, there.